Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial, we are going to be taking a look at the doubly linked list data structure. Now in the previous couple of video tutorials, we've discussed the singly linked list data structure. So if you've missed those videos, I'll link the entire data structure and algorithms playlist in the video description, and you can also see a card on the top right corner. If you don't know what linked lists are, do check out this entire playlist. I have also covered linked list in detail in a separate video. So with that being said, let's start off with today's topic. So just like singly linked list, so we already covered this one. So just like singly linked list, we are going to be dividing this doubly linked list into two parts. So in this part, we are going to be discussing what is doubly linked list, how is it different from singly linked list, and the various operations of doubly linked list. We are also going to be seeing the algorithm and our approach basically of how we are going to be tackling this doubly linked list data structure in terms of pseudocode and algorithm. Now mind you, there are many different ways in which you can implement doubly linked list when it comes to programming. So that's why in this video we'll discuss how we are going to be tackling this problem. And as I mentioned, you'll find n number of different ways on the internet if you see the implementation of doubly linked list. So in part 2, of course, we'll write the code, but in part 1 we need to understand our approach. So with that being said, let's get started. So talking about the difference between doubly linked list and singly linked list, as you can see from the diagram, we have one extra data member which is known as the previous pointer, and here you can see it points back to the previous node, right? So in singly linked list we only have the next pointer. So if this is n1, n2 and n3, you can go from n1 to n2, n2 to n3, and this is the head node, but you cannot come back, right? So this is not allowed. However, here it is possible because there is one extra data member which is a pointer which is known as previous pointer. So if this is n1, n2 and n3, you can go from this direction, that is n1 to n2 and n2 to n3, but you can also come back using the previous pointer, right? This previous pointer is going to point to the previous node. So this is the major difference between singly linked list and doubly linked list. And now let's actually move on to how we are going to be creating this doubly linked list, what is going to be our approach and all the operations. So just like singly linked list, we are going to be performing 6 different operations. The first one is traversing a linked list, which means going from node n1 to node n2 to node n3, and in this case we can also go back. So that's traversing, that is traveling from one node to another. We have append a new node to the end of the list. So appending is adding a new node at the end, okay, and making these connections. So that's going to be appending. So if we have n1, n2 and n3, we will have one more node which will be attached at the end. Okay, so this is the head, that is the starting point of the list, and this is the end of the list, So after the end, we have to append this node. So appending basically means adding a node at the end. Similarly, we have prepend a node, and prepend happens at the start. So we will prepend the node over here, that is attach a node over here. And one thing that we have to do is we have to change the head to point to the newly prepended node, okay? Because now this is the new head, right? So that's prepend operation. We have inserting a node to a specific position in the list. Let's say this is node n1 and n2. And now we want one more node, n3, which has to come in between n1 and n2. So what we have to do is, so this is n3. So here what we'll have to do is we have to point this next pointer of n1 to n3. So in n3 also we will have n and p pointers, right? So n3's previous pointer should be pointing back to n1, right? Now n3 needs to point, that is the next pointer inside n3 needs to point n2, and the previous pointer of n2 should point back over here. So these are the connections to be made, and only then you can erase out this connection. So now it becomes n1, n3 and n2. So that's inserting a node to a specific position inside the list. We have deleting a node from the list. So again, there are 3 different variations. Let's say you want to delete the very first node, that is the head node. Then the only thing that you have to do is you have to point head to the next node, and this gets erased. So next time the list will start from n2, right? Then we have deleting a node at a specific position. Let's say you want to delete out this center node. So in that case, what has to be done is when you delete this, before deleting, you'll have to make other connections, right? So you have to point the next pointer of n1 to direct n3 instead of n2, right? And the previous pointer of n3 should point to n1 instead of this one, right? So these two links have to be broken, and then n2 will be unchained or unlinked from this doubly linked list. You don't have to actually delete the object. We're going to be talking about objects as we move ahead. but you just have to unlink the links. Okay. And lastly, we have updating a node in the list. So let's say the data, that is the D part inside N3 is storing an integer value 5 and you want to change it. So how will you change it? You will first have to traverse from N1 to N2 to N3 because the head starts from N1, right? So you have to traverse to this N3, access this node and then change the data member. Let's say you want to change it to 10. So change it to 10. And how are you going to uniquely identify this node? By passing a key value. So along with previous pointer data and next pointer, we will always have one more data element inside every node which is going to be key. Okay. So right now I did not show it over here because it's for representation purpose, but when it comes to actually implementing it, when you want to uniquely identify one single node, you identify it by its key. Okay. So you add one more data member. So let's see how that goes as we move ahead. Let's see the individual algorithms. Okay, so on the left, as you can see, I have a code in C++ because we are going to be implementing the doubly linked list using C++ programming. So I have this code for the class node. Now you can also use structures if you're using C programming. We are going to be using the object-oriented way. That is, we are going to create a class because we want our object to have previous pointer, next pointer, a key that uniquely identifies this object and the data, right? So that can be done using our user-defined data types, which is classes. So in the class, you can see I have int key, int data. I'm keeping integer data members to make it simple. And then we have pointers which are of class node itself. That is the same class because they are going to be pointing other objects of the same class only, right? So that's why we have to keep the class same. You'll understand more when we actually code. And we have next and previous. And then of course we have some constructors. So this is the default constructor when the key and data becomes 0, 0 and next and previous pointers are pointing to null. And then we also have parameterized constructor. Now these are all C++ programming concepts. I have a complete separate C++ programming tutorials playlist right from scratch. If you don't know what C++ programming is, you can view that. So in the parameterized constructor, we are going to be passing the key and data. And of course the next and previous pointers are always going to be assigned null when you first time create a node object, right? So how does this work when it comes to the programming part, when it comes to the implementation part, and what happens behind the scenes? So let's see that. So let's say this is your int main function, inside which you create your object n1 and n2. Now n1 and n2 are of class node and we are passing key as 1 and data as 10, key as 2 and data as 20, right? So we are using the parameterized constructor. So what does happen in the computer memory where your program is running? So in the computer memory, what happens is 2 memory blocks are allocated, right? So let's say n1 object is created at the memory address #10. We know that the key is 1, we've passed it, we know the data is 10 and the previous and the next pointer are going to be null because that is what is assigned when you create it for the first time. Similarly, n2 is created at some random location. It's not contiguous, right? Memory can be allocated anywhere. So this memory address is 70. Then we have key as 2 and data as 20. Okay. So this is what is happening so far. Now this is still not a doubly linked list. We have just created the nodes. Now to make a doubly linked list, what we have to do is we have to make the connections, right? We have to change the address of the next pointer of n1 to point to n2. That is, the null should be storing #70, which is address of n2. If you want n1 to be the first node and n2 be the second node, or vice versa, will also do. Basically what we have to do is we have to change the address storing mechanism over here. So that is when we have to create one more class of doubly linked list and create another object D or any object name and then make those linking possible. So let's see how that goes and let's see the individual operations in terms of code, how they will look. Okay, so as you can see, I have created more objects n3 and n4 and they are also created in the memory. Now at this line you can see I've created a doubly linked list object D. And I'm not showing the code over here because that code is going to be huge and we will see that in the part 2 when we actually implement it. But just assume that we have one more class doubly linked list and we are creating an object D. Inside that class or inside that object we have one data member which is going to be the head pointer. Okay, so that is depicted over here in this diagram. So this green box is basically just an imaginary box inside which we will create the linked list where the linking will happen actually. Okay, so this is just the diagrammatic representation. Now next line says d.append node and we are passing n1 as address Now we are not getting into the programmatical details right now. Just understand that what we are doing is we are saying d.append node. So we are using the append operation and we are appending n1. So for the first time, you can see that the doubly linked list is going to be empty, right? We only have 4 individual nodes in the memory created at 4 different random locations, and there is no linking happening. So for the first time, all of their pointers, that is the previous and next pointer of all these 4 objects, is going to be null. So for the first time, when we say append node, what will happen? Let's see the algorithm. So step number 1, get the new node. So the node is n1, we are passing it inside this function, or you can say method. When it comes to classes and objects, the functions which are inside the class are known as method. Basically, they are the same. So the next thing is check if the node exists with the same key. Now remember that every node needs to have unique key. You cannot have nodes having duplicate keys, because then we cannot access them, right? When you want to update them or when you want to delete them, we have to access them by the unique keys. So this is what the step number 2 says. Check if the node exists with the same key. Now initially, when you first time are appending a node, you can see that there is no node actually inside the doubly linked list. That is, we have not yet formed the linking not even one time, right? So if true, abort, but we know it's not true. So 2b is going to be executed. If false, continue. Now 3a says if head equal to null, then append at the start. So when you create this doubly linked list d object, the head pointer inside this doubly linked list d is also going to be equal to null only, because it is created for the first time, right? Now here the condition says if head equal to null, then append at the start, which basically means now the head pointer will point to the address of n1. Okay. Now we know the address of n1 is #10, right? So let's write that. So the head pointer is now pointing #10 or storing the address #10, right? So what I'll do is I'll quickly create this n1 over here. So this is n1, this is null, this is also null. We have key as 1 and data as 10. And our head pointer is pointing to n1. Okay, so this is what is happening at this step. Let's move on to step number 2. Now we are saying d of append node n2. Now again, append function is called, or append method is called. Now this time we know that head pointer is not null, right? So till here the steps are going to be the same, that is till 3a. At 3a we know that if head equal to null, we know head is not equal to null. Head is having an address of #10. So 3b will be executed. Now 3b says else traverse to the end of the list. So when you are traversing to the end of the list, what is happening? We know that n1 is the only element in the entire doubly linked list. So after n1, we are basically at the end only, right? So this is where the end will be. And then step 4 says append new node at the end. So when you say append new node at the end, what is going to happen is we have to change this address, right? So what we have to do is we have to take the n2, we are appending n2. So let me create n2. Let's say this is n2. The key value of n2 is 2 and the data is 20. The next pointer inside n2 is null and the previous pointer is also null. So now what we have to do is we have to make this linking of n1 to n2, right? So how does this linking happen? We have to change the next pointer of n1 to point to n2, and we have to change the previous pointer of n2 to point to n1. So let's make those changes. We already know the addresses of these two things or these two objects. So let's do that. And now you can see we have changed the addresses and now they are pointing to each other. So basically what we did is we made our very first connection, which is n1 now points to n2 and n2 also points back. Okay. So this is the first link happening. So this was append node algorithm or pseudocode. You can also write it down. We will be converting this to C++ code when we actually go ahead with the implementation part in the part 2 of this video. Let's move on to prepend node algorithm. Okay, so when it comes to prepend node, we know that the prepending happens at the start of the node. So first thing we have to check and we have to take the new node. The new node that is supposed to be prepended is n3. We have to check if the node exists with its key. So we know that the unique key of n3 is 3, and in the entire doubly linked list that is comprising of n1 and n2 for now, we don't have a key whose value is 3, which means that this is unique. So this is allowed, right? So if key exists true, we have to abort, but we know that the key doesn't exist. It is a unique key. So if false, we have to continue. Now step number 3 says head of previous is equal to new node of next is equal to head equals to n. So let's try to decode these 3 lines. The first line says head of previous is equal to new node. Now this new node over here is n3, right? This is what we want to prepend. We know that the head currently is pointing to n1. You can see it over here in the diagram itself. Now head of previous, which means head is pointing to n1. n1 of previous is what? Null. You can see right now it is null. So we are saying head of previous is equal to new node. Now this new node is passed by address, right? So we want to store address of n3 in the previous pointer of n1 because head is currently pointing n1, right? So this null is now erased. We know the address of n3. You can see it in the memory RAM. n3 is created at hash 45. So hash 45. Let's create n3 over here. So what happened is now this n1 is pointing to n3, right? This pointing is done. Let's move on to step number 4. Step number 4 says new node of next is equal to head. Now initially this is going to be null, right? But now we are saying this new node is n3, right? We know new node is n3. n3 of next is going to be head. The head pointer is still storing address of n1. So this address of n1 is now going to be stored at this location over here. So let's erase this and let's change it to hash 10, right? New node of next, that is n3 of next, will store the address which is there in head. And head is storing hash 10, which is head is pointing to n1. So now this address is stored. So this linking is done, right? So step number 4 clear. Now moving on to the last step, head is equal to n. Now we've made the linking over here, but now we know after prepend, the new head is n3 and not n1, right? So the head pointer is still having hash 10. So that also has to change, right? So now we say head is equal to n. And now n is basically this newly passed n3. Okay. So basically head is equal to new underscore node. Okay. So we just have to erase this address and this linking. And now head pointer will store address of n3. This is newly passed node. We know the address is 45. So the address is going to be hash 45. So now the head pointer is going to point to this n3. And this is the start of the doubly linked list and not n1. So these are the 3 different steps which you need to understand, and this is the entire algorithm or pseudocode for prepend node. I hope you are understanding it by the diagram. So basically what has happened is we have created one more link over here. In the memory diagram you can see n3 is basically pointing to n1 and n1 is pointing back, and the head is actually n3. Okay, so this is the head. That is, the head pointer is pointing to n3. Okay, in terms of programming. Okay, so this was prepend node. Now let's understand insert node after. Okay, now the pseudocode or algorithm for this is a little bit lengthy because there are multiple conditions again. So let's go step by step. First, get the new node and the key of the node in the list after which you want to link this new node. So what we are saying is insert node after, we are passing the key of the node after which you want to append this new node, right? So 2 data things or 2 parameters you have to pass. You have to pass the key. So I'm passing 1. Now key value 1 is of n1. So what I'm saying is I want to append n4. This is n4 newly created node after n1 but before n2, right? So this is where we want to append or insert. Basically this is not append, it is insert n4. Okay, so I hope you are understanding this. So that's why 2 parameters. So this is step number 1. Now we have to check if the node exists with the same key as the new node. So again we have to check for any node having key as 4, and we know right now we don't have anything, it's unique, so it is valid, right? So if true, abort, and if it is unique then continue. So right now to keep it easy we are going with unique things only. The step number 3 is check if the node exists with the key entered by the user. Now we also have to check for the node having a key value of 1, right? So in the entire doubly linked list, if you enter something random, let's say 7, so we don't have any node having the key as 7. So we have to check for that also. So that is happening at step number 3. So if user entered some random key which is not there, we have to abort, else you have to continue. So till 3b it is basically just us checking for validations. Real things start after step 4. Now, At step 4, what we have to do is we have to access node n, after which you want to append the new node new underscore n. Okay, so this node n is the node after which you want to append the new node. Right now, in the insert node after operation or function, n1 is basically n. So let me just write it down over here. N is equal to n1, and this new underscore n is the new node n4. Okay, so we have to first access n1, and in step number 4a, what we have to do is we have to check if this n is at the end. Now we know that n1 is not in the end, it is in between n3 and n2. So if it was at the end, let's assume that we passed value 2. Okay, so that would mean that we have to access n2, and n2 is at the end. So when n2 is at the end, what we have to do is we have to just say n of next. Now this n again would be n2 over here. So n2 of next is equal to new n. So what I would do is I would just say n2 of next, that is next pointer of n2, to store the address of n4. We know the address of n4 is hash 90 over here. You can see in the memory. So I'm just going to say hash 90. Let's assume this was n4, and then this linking would happen, right? Similarly, I would say new n, that is n4 of previous. So this would be null and null initially, right? That is the previous value, and the next pointer of n4 is also going to be null initially. So I'm going to make it point to n2. This is what is being shown over here at this step in the algorithm. We are saying new of n of previous, that is the previous pointer of n4, to point n. Now n is n2. Now we know the address of n2 is hash 70. So hash 70 will be stored. Okay. So this is how the linking will happen if n is at the end, right? But we know that what we passed initially is 1, and the node having key of 1 is n1, and it is not in the end, it is in between, right? So I just showed you what happens when the node is at the end. Now let's see what happens when node is in between. So 4b is the step when n is in between. So here's what is happening. If n is in between, new node of next is equal to n of next. Okay, so what just happened over here? First, what I'm going to do is I'm going to just shift this n2 over here because we have to insert n4 over here. So let me just show it to you. Okay, so what I did is I just shifted n2 over here because n3 is supposed to come in between n1 and n2, right? So this is where we want to insert n4. So we are passing n4 and we want to insert n4 after the node having key as 1. Now key is 1 of n1. So this is where we want to insert it in between n1 and n2. Okay. So currently what is happening is after n1, direct n1 is pointing to n2 and the previous pointer of n2 is pointing to n1. Now we want to change that. So let's see what are the steps. So step number 1 says new n1 of next is equal to n of next. Okay, what is new n? New n is n4, right? This is what we declared over here. Now new n of next. So n4 of next currently is null, right? So what do you want to change it to? New n of next is equal to n of next. What is n over here? N is n1 and n of next is the address, right, which is 70. So this is that. So we are saying n4 of next, which is null, to store n1 of next, which is hash 70. So let's make that change quickly. So we did hash 70. Now hash 70 is address of n2, right? From the memory chart you can see this is that address of n2. So what we did, we linked this, correct? Let's see this step now. Now at this line, what we are saying is n of next of previous. So what is n of next currently? Now we know that n is basically n1, right? So what is n1 of next? n1 of next is currently pointing to n2, right? This is what the linking is currently. We are saying n of next of previous. So we are going from n1 of next, which is n2, right? Because n1 of next is having hash 70. Hash 70 is address of n2. So we are accessing n2 and then we are saying n2 of previous. So we are saying n of next of previous, which means n1 of next, which is n2, and n2 of previous. So we are accessing this n2 and we are saying n2 of previous is equal to new n. Now new n is n4. Now n4's address is hash 90. So we are changing hash 10 to hash 90. So let's do that. Okay, so what did we do? So we are saying hash 90. Now hash 90 is the address of n4, right? You can see over here. So n2's previous pointer is now pointing to this newly created n4 object. So these two linking are done from this and this line. I hope you understood this step. Now let's move on to the next. Now we are saying new n of previous is equal to n. New n is n4, right? So n4 of previous. Now n4 of previous is currently null over here, you can see. Now n4 of previous is equal to n. Now n is n1. So n1's address is hash 10. So we have to replace and add hash 10 over here. Let's do that. So hash 10 is done. So what we did, we made this link. Also do note that when we change n2's previous to hash 90, we erase off this link. Okay. So this step is done. And now at the last step, we are saying n of next is equal to new n. What is n? N is n1. n1 of next is hash 70. But now we are saying n of next equals to new n. Now new n is n4. n4's address is hash 90. So we have to change hash 70 to hash 90. So let's do that. Hash 90. So we made this connection now and last connection is broken. And now you can see that we have done the insert node after a particular node operation. So this is done. So this was a lengthy operation. As you can see, we had multiple steps and we have to follow these steps as it is. Otherwise the linking won't happen properly. Now if you see in the entire doubly linked list, the linking is perfectly fine. First we have n3 as the head. Then we have n1. Then we have newly inserted n4 and last we have n2. And you can see the next pointer of n2 is still null. Okay. So this is done. So we did append, we did prepend, we did insert node after operation. Let's see delete node. Okay, so again in delete node we have multiple conditions. Let's quickly go by step. First thing we have to do is get the key of the node you want to delete. We have to check the node if it is existing. So let's say over here in the delete node we are just passing in the key. If you pass some random key 7, we know that there is no node having the key of 7. So you have to give an error, right? Otherwise we have to check for that node. If it is true or if it is existing, you have to continue. Now you have to check if head equal to null, then the list is empty. You cannot delete anything if the list is empty, right? And when is the list empty? When the head would be pointing to null. Remember initially when you created the doubly linked list D object, the head was pointing to null because there was nothing in the doubly linked list. There was no linking happening and that time the head pointer was having null. So that's the condition for empty list. Now we know that it is not empty. So the next condition is 3b. It says if head not empty and key matches the head node itself. So when you're deleting, let's say you pass in 3 over here, you can see that this key value 3 is of the head node itself and head node is n3 whose key value is also 3. So this 3b condition is true, right? So this matches, this condition matches. So then what you have to do is you have to just say head is equal to head of next. In that case, what you're doing is you're just erasing this link and you're changing the address and you're saying head is equal to head of next. So initially head was pointing over here. Now head of next is hash 10, right? Head of next means n3 of next basically, right? Because head is pointing to n3 object. The next pointer of n3 is having an address of hash 10. So you have to now store hash 10 over here. And now the head is now basically pointing to n1. So we did not delete this n3 object. We just changed the head pointer to point to n1. So the next time the doubly linked list will always start from n1, n4, n2. So we did not delete it. We just unlinked it. Okay. But this was only when the head pointer matched the basic node, right? So here you can see that the key that we passed directly matched n3. So this condition was true. But what if the key that we pass is not the head node? So let's say you pass key value as 2. Okay. So what happens in that case? So in that case, the head was initially pointing to N3 only. So let's do that first. Now let's say you pass the key of 2. Now we know that node N2 is having the key of 2 and it is at the end of the list. So this is the condition 4a. Here you can see if node is at the end, then you have to access the node which is one node previous to that and just change the next value to null. So what you have to do is you have to go from the head, that is go from N3 to N2, N1 to N4 to N2, and we know that we have to delete N2, right? So we have to again come back to N4 and we just have to change the next value of N4 to null. So we just have to erase this and make it null. So this basically removes this link, right? So next time when the list will start, when you traverse the entire doubly linked list, we will go from N3 to N1 to N4, and this would be the end of the list because we know that the N4 of next is going to be null. So even though we did not delete N2, we removed this link, right? So we detached it. So this is now going to be the new end of the doubly linked list. Okay, so I hope you're understanding. This is what happens when the node is at the end. Now the last condition is when the node is in between. So let's say now you pass the key of 4. Okay, you pass the key 4 over here, and we know that node 4, N4 has the key of 4 and it is in between N1 and N2. So this node lies in between the two nodes. So in that case, what we have to do is, this is 4b condition. We have to say previous node of next equals to next node. So we have to come to this node first. We have to traverse from N3 to N1 to N4. We have to say previous node. Now previous node of N4 is N1. We have to say N1 of next equal to, that is previous node of next equal to next node. Now if this is the current node, that is if N4 is the current node, next node is N2. So this is next node and this is the previous node, right? So we are saying previous node of next equals to next node. Now previous node of next means this address. We have to change it to next node address. Next node is N2. N2's address is #70. So we have to say #70. So basically what we did is we changed this link and now N1 will directly point to N2. So this step is done. Similarly, we have to say next node of previous. Now next node is N2. Now N2 of previous. So N2 of previous is this pointer. We have to change that to the previous node. Now previous node is N1. N1's address is #10. So we have to do that. So I'm going to say #10 over here. So basically what we did, we changed this to point to N1. And that's the only thing that we have to do. So what we did is we just changed two links. So the next time we traverse the entire linked list, we will go from N3 to N1, and N1 of next is now pointing to N2. So we will never go to N4. So we unlinked N4 from the doubly linked list. We did not delete it, we basically unlinked it. So yeah, this was basically the delete node operation, or you can say delink node. We did not actually delete it. So this is done. Let's move on to the last update node. Now the update node algorithm is very easy. We just need the key of the node and the new value to be updated. Okay, so here you can see we are passing 4 and we are passing the new value. So we just have to take the key of the node you want to update. You have to check the node if the node exists with that particular key. If false, then you have to abort. If true, you have to continue. And when you say continue, you have to traverse to that node. So right now we are passing 4, right? So we have to go from N2 because N2 is the head. We have to go to N1. Then from N1 we have to go to N4. Right now we are passing 4. Let's pass actually 2 because we have unlinked N4 in the previous operation, right? So let's say the key is 2. So you have to go from N2. We have to check the key. Key is 3. It is not equal to 2. We have to go to the next node. From N3 I will go to N1. Again I'll check the key of N1. Key of N1 is 1, which is not equal to 2. Then I'll jump from N1 to direct N2 because N4 is actually not in the list. We have delinked it. Now here the matching key is found. Now we have to just change the value of 20 to 55. So that's the only change. So I'm going to erase this out. I'm going to change the new value to 55. So that's the update node operation. And yeah, these are the main standard operations. There are more operations also, like reversing the list or inserting node before a particular point, but we are going to be implementing these operations first. If you want more operations, you can let me know in the comments. And yeah, this was the end of the entire part 1 of Doubly Linked List. I know this was a little lengthy, but it was very important that you understand how the algorithm works, what happens behind the scenes, and how the linking happens in the memory. So that's it for this video, guys. I hope you have a clear picture of the approach that we are going to be using in the next part when we actually implement the Doubly Linked List using C++ programming. And quick disclaimer, guys, this is not the only way to implement Doubly Linked List. There are many different ways also, but we are going to be taking this approach. So thanks for watching, guys. If you've made it so far, please give this video a like. Let me know in the comments how this video was. Do share it with your friends. And if you haven't yet subscribed, please subscribe to this channel. That would be very helpful. So see you guys in the next video. Peace.